Hello, class. This is when we're going to learn how to define and find the three basic trigonometric ratios. First, as a bit of a warm-up, I'd like you to answer these three questions. See if you can name the sides opposite the indicated angles. So the side opposite angle A is the side of the triangle that isn't one of the sides of the angle. And so angle A is made up of rays AC and AB. So the opposite side must be side BC. Opposite angle B is segment AC, and opposite angle C, side AB. Now, another way that in mathematics we name sides of a triangle are we take the name of the angle and we name the opposite side with the same name but a lowercase letter. And so mathematicians are precise but also lazy when we can get away with it. So using a single letter instead of two letters is, it's a little bit shorter than using two letters and a little bit simpler. So we get away with it when we can. And so why is this useful? Well, if you're just given the names of the sides, you can name all the angles and vice versa. So if you only have partial information, you can fill in the rest of it using this convention. So a little bit of vocab before we go any further. This symbol is a Greek letter. It's called theta. And it pops up a lot as a variable in problems involving angles. So we're going to see that in a lot of trigonometry problems. And here we have our right triangle vocabulary. We've already talked about hypotenuse before. And we just looked at opposite sides, but a new term for you might be adjacent side. And the word adjacent literally means next to. And so it's the side of the angle, the side of the triangle that is next to the angle. So what do we mean by that? Let's look at an example. So when we go through trigonometry examples, you always label all of the sides. And here, we're going to say that angle B is our right angle. So on the left is my blank triangle we're going to start with, and on the right is the one we're going to mark up. So angle B is our right angle. And we're going to name all three sides. But we have to name it in relation with respect to one of the other acute angles in this triangle. So in this case, we're going to use angle A as our acute angle. And we already saw that the opposite side here would be side BC. So we're going to call that opposite and use OPP for our abbreviation. The side adjacent to angle A is the leg that forms the angle. It's not the hypotenuse. So the leg next to this angle would be AB. And we use ADJ for our abbreviation. And the hypotenuse, longest side opposite the 90-degree angle, a tricone hypotenuse. That's what we label the three sides. Now, how would this naming change if we had used angle C instead of angle A? What would be different here? Well, the hypotenuse wouldn't change, but the opposite side and the adjacent side would flip, because now for angle C, AB would be opposite and CB would be adjacent. So you have to be careful when you're changing the angles that you switch your opposite and adjacent legs. The hypotenuse won't ever change. The hypotenuse is always going to be the same no matter which angle you're looking at, always the longest side. So here are three examples, make this a little bit bigger. And I'd like you to take a moment to practice labeling the three sides using adjacent, opposite, and hypotenuse with respect to the marked angle. So number 4, you'd use F, number 5, R, and number 6, K. So try that now, and then I'll show you my solutions. All right, here are my solutions. Number 4, number 5, and number 6. So here's 3 problems that all correspond to this triangle here. We want to figure out the opposite over hypotenuse ratios for angles A and B. So for angle A, the opposite is 12, and the hypotenuse is 13. But for angle B, the opposite side is 5, and the hypotenuse is 13. Okay, let's do something similar, but now use the adjacent side, adjacent over hypotenuse. So for angle A, the adjacent side is 5, and the hypotenuse is 13. For B, the adjacent side is 12, and the hypotenuse is 13. So what do you notice about these numbers? What's the relationship between these ratios? Well, the numbers, each of these pairs has the same numbers in them, they're just in a different order. So the opposite over hypotenuse ratio for A is equal to the adjacent over hypotenuse for B. And the same is true for the other ratios here. That's going to be an important property we're going to see. So these ratios, they might not seem immediately useful, but we're going to use them to solve a whole variety of problems with trigonometry. And like I said, we like to use shorthand in math. Instead of calling all these ratios opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent, we have special names for them. And these names, they're called the trigonometric ratios. And the three names that mathematicians use are sine, cosine, and tangent. And these, I guess, have deeper meanings. Not really important right now, but in Algebra 2, you'll talk more about the meanings behind these terms. So the first ratio is called the sine of theta. It's going to be opposite over hypotenuse. The second one is the cosine. That's going to be the adjacent side divided by the hypotenuse. And finally, the last ratio is tangent. The tangent ratio is the opposite divided by adjacent. And so you have to memorize these. There's a little mnemonic phrase to help you memorize them. It's called SOHCAHTOA. So sine is opposite over hypotenuse. Cosine, adjacent over hypotenuse. Tangent, opposite over adjacent. SOHCAHTOA. So you have to have that in the back of your head. Here we have a triangle, and they give us angle measurements and side lengths. We want to complete our table. So here they give us two different angles. We want to fill in each row. So let's start with the angle that measures 53.2 degrees. So what's the sine of that angle? Let's label our sides. With respect to P, the opposite side is 4, the adjacent side is 3, and the hypotenuse is 5. And let's put down our little reminder, SOHCAHTOA. It's going to help us out. So let's see, sine opposite over hypotenuse. In this case, that would be 4 divided by 5. For the cosine, adjacent over hypotenuse, that's 3 divided by 5. And tangent, 4 divided by 3. Now let's do the same thing, but we're going to change the reference angle. So we know that when we change the reference angle, we have to change the adjacent and the opposite sides. Now if we use angle Q, 36.8 degrees, the adjacent side is now 4, and the opposite is now 3. So sine is now 3/5, cosine 4/5, and tangent 3/4. And that's our table. So this is how you can figure out, for a given angle and all the side lengths of the triangle, how to write down the three different trigonometric ratios for the given angle. In this lesson, we learned how to define and find the trigonometric ratios. Thank you for watching this video.